Hey there, Ken here again from NoBrainer. I've got another math exercise sent to me by one of my GMAT students. This one came from Cadol, and let's get right down to it. Today's exercise is a math data sufficiency question from a GMAT practice exam. So let's have a quick look at it. You've got a triangle figure as a diagram, right triangle RPT, and the question is, in the figure shown, what is the value of x? There's two data statements. The first one says the length of line segment QR is equal to line segment RS, and the second one says the length of line segment ST is equal to the length of line segment TU. Let me zoom in just to show you the diagram a bit clearer. I'll zoom back out, and if you want to try this, pause the video now and then start it back up again when you want to see my solution. Give it a shot. Okay, so let's get started. The first thing I always tell my students to do in geometry on the GMAT is to redraw the diagram, especially if it's a complex diagram. So I'm doing that now, and we want to, when we're doing this, we want to start bringing up in our heads the various theorems and properties about the shapes we're dealing with that we probably are going to want to know. So we have a triangle clearly. It's a right triangle due to the right angle here. And we also have a strangely shaped quadrilateral in the center with one of the vertices having the degree of x. Now, let's look at what we know and what we don't know. We know this is a right triangle, and we basically don't know anything else at the moment without going to the data statements. So data statement 1, actually in this case both data statements give us information about different line segments in this graphic. The first one says line segment QR is equal to the length of RS. QR, RS are equal. So with that information, what do we know? Does that give us anything new? And what you would want to recognize here is this demonstrates this here triangle QRS is an isosceles triangle with these alternate interior angles equal to each other. So what I'm going to do is label these Y. Okay, and at this point we still don't have enough information to get at this value x degrees here, but we do know now that these angles are equal to each other. When we look at data statement 2, the length of ST equals the length of TU, now we have these two sides, line segments, equal to each other. And similar to the triangle above, we can label these alternate interior angles Z. So now the question is, can we use this information in such a way to get at angle X? The first thing, now what you want to do now is really expand your mind a little bit more and realize how many shapes are we actually dealing with here. We've got the large shape, that's one triangle. We have this isosceles triangle, and here is 2. This other one, 3. And this oddly shaped quadrilateral, 4. And we can hypothesize that without both of these pieces of information, we're surely not going to be able to get at angle X. There's just not enough information here to get to it. Some might still think they don't know how to approach it, but what you want to do is start writing equations using algebraic properties of geometry that we know and see if we discover a pathway to X. Well, one thing we might recognize is that these angles are all supplementary, right? X plus Y plus Z equals 180 degrees. Great. So that's one piece of information. Now we know we have 3 variables, and generally speaking, if we have 3 variables, looking to solve for x, we generally would be looking to create 3 equations. Let's see what else we can create. We might also recognize that the supplementary angle to this y is simply going to be 180 minus y. And the supplementary angle to this z is going to be 180 minus z. Additionally, we might recognize that angle r is simply going to be 180 minus 2y, and angle t is 180 minus 2z. Why? Because of the property that every triangle, so 3 interior angles, must add up to 180 degrees. So we now have all these different angles represented with 3 variables x, y, and z, and there's all sorts of equations we can write. Here was the first one, and hopefully right now you could have the foresight to realize that you can create an equation for this triangle in terms of y. We can create an equation for this triangle, the large one, in terms of y and z, and we can create an equation for this quadrilateral in terms of x, y, and z. Lots of equations, and perhaps you'd go ahead and choose C, which happens to be the right answer here. But if you wanted me to write the equations out for you, I will continue a bit farther. So the large right triangle simply would give you 180 minus 2y plus 180 minus 2z plus 90 equals 180. That's another equation we have. And the quadrilateral in here is simply 180 minus y plus 180 minus z plus 90 plus x equals 360. Now, here's 3 equations with 3 variables, and I won't take this any farther because in data sufficiency it's all about knowing when you can solve, not actually solving for the answer. What we're looking for, again, if you remember, was the value of x. Clearly, with both data statements 1 and 2 together, we can get there. So that wasn't too bad, was it? Look, with geometry, data sufficiency, it's important to just simply remember, redraw the diagram, attack it for all the pieces of information that you know, and expand your mind and find information inside of the diagram that perhaps wasn't presented to you so explicitly at first. And for data sufficiency, the key is not to solve all the way, but to know when you can solve or answer the question stem. That's where you stop and move on. In this case, the answer was C. We needed both pieces of information, and that's it. You can move on. I hope this was clear. Follow me on YouTube for more exercises like this, and start making these exercises more of a no-brainer. See you next time.